Myself Srinivasan, working as a faculty in the Department of Mechanical Engineering at Sri Shanmugha College of Engineering and Technology. The last couple of lectures we have been discussing about convolution neural network. The convolution neural network is widely used for image and video analysis. Today we will see why recurrent neural network is important for the case of sequential data. And as far as CNN and ANN architecture is concerned, it won't work for sequential data. So both expects fixed size input. Okay, so that is the reason we have to move forward towards RNN. At the same time, it doesn't have any memory. Okay, suppose if there is a sentence called sentence, if there is a sentence like if it rains today, the match will be cancelled. Okay, so in natural language processing, it should look at what was discussed earlier. So the match will be cancelled is based on the sentence like if it rains today. Okay, so it doesn't have any this architecture, ANN and the CNN architecture, they don't have any memory of past input, so it won't work for the case of sequential data. And in ANN and the CNN, and for each input features there will be a associated weight. Okay, so for example, I can say the red traffic light appears on Tuesday, it will have one weightage. The red light appears on Monday, it will have one more weightage. Okay, so it varies from case to case. So for each input you are supposed to give certain amount of weight. Okay, so if you look at the sequential data, sometimes the word will appear several places. Okay, so you have to learn the pattern once. It has to apply anywhere else, everywhere in the document or everywhere in the image, and wherever it is. Okay, it is supposed to apply. Okay, so that is a reason we have moved forward towards recurrent neural network. At the same time, it doesn't have, if you look at the CNN architectures, and when you apply a kernel size of 3 by 3, it will focus on the certain size. Okay, it won't look at the long range dependency. Okay, so for example, as I said before, if it rains today and the match will be cancelled. So this is a long range dependency is there, because if it rains today is the most important thing to decide whether the match will be cancelled or not. So in that case, the ANN and CNN will not work at all. Okay, so whenever you type in Google, and automatically you could be able to see the next word, what is going to be the next word. Okay, so it all depends on the whatever you type in a search bar in Google. Okay, so this works based on the recurrent neural network. Okay, so why it is special about why it is totally different from CNN? Because it remembers the information whatever we have said. Okay, it understands the context. At the same time, wherever the pattern is there, it is able to recognize. So these are the qualities it has. That's the reason we have moved towards recurrent neural network. If you look at this, a boy is going to play football. He is playing football and he is going to kick it off the ball. And if you look at each frame, considers a input. So it doesn't have any meaning at all. Okay, so the order in which it is framed, that is very important. The order is very important. The input is not important in this case. So this is the architecture of recurrent neural network. Okay, so we have a input here. It will have associated weight. Okay, and it has a hidden state, and finally it will have one more weightage, and whatever it is here, it is both summation activation happens here, and again it is whatever comes out, it will have a weightage, or it will have a weightage again, it will get predicted. So this is a way it works for the neural network systems. See, if you look at this this input, so what is happening here, it has some associated weight, because WXH, so the weights for the case of input and to hidden. Okay, and similarly the previous hidden output is going to come over to this hidden state. Okay, because the previous input is stored here. Previous input is very important in this case. So it will have some associated weight over here. Okay, it is associated with some weight, and all will get summed up and getting activated, and finally whatever the output comes out from this HT will get multiplied with this, and finally we will get this output. Okay, so in recurrent neural network system, it all depends on the previous step. Okay, so if you look at this expression, okay, it is a function of this, pi is a function of this, wx is this one, the xt is this one, wx this one is from here, okay, and xt is from here, and the previous output of the first one, this hidden is here, and this is the weight sharing between two hidden layers is this one, and the bias term is also added over here. Okay, so this is the way it works out. So the information is very important for previous information is very important for the where it is going to predict in the particular architecture. Okay, so the output is basically, it is another function of this, and whatever comes out whatever comes out from here, okay, whatever comes out from here, okay, and it is associated, it will be multiplied with the weight associated with between this this one why, then bias term over here. So the final output is this. So the final output is going to be this one. Okay, so similarly, this is for the case of one layer. Then if you will have multiple sequences. So it starts from, maybe I can say t power t minus ht minus n and ht plus minus 1. So then ht, then it goes on. Corresponding outputs are written over here. Okay. So what is happening if you look at this RNN architectures? You are able to see the weights are going to be very same across all the cases. Okay, so in AN and CNN, each input feature will have different weights, but as far as RNN is concerned, the weight is shared across the architectures. So what is happening? It is able to learn the patterns and remember the information from the previous layers, and whatever may be the size of the word or sentence or sequence. Okay, so it shares the weights across the time. Okay, so that is the beauty of this recurrent neural network. So this is unfolded architecture. This is, I can say, this is a folded one. This is a weight actually. So this is a folded architecture of a recurrent neural network. So we have many types of recurrent neural network. So one is many to one, and one to many, and many to many, and the many to many will have the same length, and another is variable length. This we are going to look at in the forthcoming slide. So if you have one to one, it is not, I cannot say it is a recurrent neural network, that it's a simple architecture. It doesn't have any sequential data. Whatever the input you are giving, it is getting summed up and activated, and finally we will get the output over here. This is called one to one category. Okay, suppose if I want to measure the temperature at a particular time, and we can able to say what is the temperature after t plus 1. Okay, so that is a one to one architectures. Okay, so what is next thing is one to many. Suppose if you give an image here. Okay, so if you give an image here, and you will have multiple outputs. This is input is 1, I can say input is 1, output is many. Okay, so if you look at this architecture, if you give the input, and it will get summed up, and it will get fired, and finally we will have an output. Okay, the same way what we discussed. So because since we don't have many inputs, we have only one input. Okay, we don't have many input, only one input. So what is happening here? Then here, whatever the output comes, whatever the output, that is going to be the input for the next hidden state. Okay, so this is the way it works. So it uses the previous output as input. So that's why this formula is totally differs, because if you look at this one, this is a H2, this H1 of this, and the output of this is the output of this. If you look at this formula, this is the output of the first state. Okay, output of this H1. Okay, so this is the way it works. Suppose if you give a image, in that you will have a dog, grass, and many things are there. Okay, what it does is, it tries to capture the important things like dog, grass, and everything. It tries to read the things in the image and find first the word comes out from here is A. Then again it goes back, the output goes back and to the next one. So as a result, it is and another word it predicts dog, and again it sends back to the RNN architectures, and the next word is basically a dog is running. Okay, similarly next word goes back and says the dog is a dog is, I can say the dog is running in the grass. So what is happening when you give an image of one, and if dogs runs on the grass, and the moment it captures and you try to analyze what other things are there, and the first word it predicts is A, and the first word it goes to the another input of the next layer, and finally you are able to say the dog is running in the sequential data. Okay, so that is the way it works in one-to-one case. And we have many inputs, but only one output we are going to get. Okay, first of all, this is a picture, and it is a picture. This picture is basically for the Surya Namaskar. Okay, so whenever we give the many inputs, and finally it says this position is basically a Surya Namaskar. If I give the inputs like the movie is good, you will have many inputs, but finally it will give you the positive one, because it works in the case of sentiment analysis. Okay, the predicting reductions. So the moment you give the sequential data, your output is going to be a number or whatever the single data. You will give integer numbers and so on. So based on that, you will get only one output you will get. Okay, so it could be a number, it could be a integer, it could be a word, or whatever it is. Okay, so this is the way it works for the case of many to one. There are another category is called many to many, and in that case when you give this you are doing great work. Okay, so what is happening, you are giving the 5 letters or 5 words, you are giving 5 words and in English, and it is getting translated into Hindi. Okay, so when you get the similar, the input size is same as output size, and that comes under that comes under the category of same length. When you say the input size is different when you say the input size is different from the output size, then we can say it is variable length. For example, if in English if you say let us run, in Hindi or in Tamil or any language that you use, it is going to be different. The size of the output is going to be different. Okay, so in that case we can say that's why we can say the many to many will have both categories. If the input size is same as output size, that comes under the category of same length, and if it is varies, then it is going to be the variable length. Okay, so that is the way it has been classified. Okay, in types of RNN, 1-to-1 and 1-to-many and many-to-many. In many-to-many you have same length and variable length. Okay, so this is a classification. These are the various types of recurrent neural network. Thank you.